Hello everyone. Now we learn how to determine the elongation index. For elongation index, the sieve used are 63, 50, 40, 25, 20, 16, 12.5, 10 and 63 mm. Then we will find the elongation gauge. The elongation gauge is equal to 1.8 into mean value of sieves. Suppose you have to find the elongation gauge of 40 mm passing sieve and retained on 25. So elongation gauge will be 1.8 into mean value of these two value. Now we are finding for passing through 50 and retained on 40. So elongation gauge will be 1.8 into mean value of these two values. So 81.0 mm. So we will find elongation gauge for all the sieves. After finding elongation gauge, we will sieve the sample and we will write weight retained on the sieves. For sieves, after sieving samples, there is no metals retained on 63 and there is no metals retained on 50 mm, and this is the samples retained on 40 mm, and these two samples, these samples and these samples retained on 25 mm and passes through 40 mm. Similarly, like this we have to find. Now we will calculate the percentage of weight retained on this elongation gauge. This is the elongation gauge. In this one, like this, passing through 50 and retained on 40. So this is, if you will test this material, means passing through material which passes through 50 mm and retained on 40 mm. So we will check through like this. Similarly for this. This is the material which passes through 50 and retained on 40. So there are no material retained on elongation gauge. Similarly, we will find the metal which passes through 40 and retained on, we will check like this. So retained. These are passing. So these are, we have already done. This is the passing and these are the in sieves retained materials. So we have calculate for all the sieves like this from elongation gauge. So already we have calculated and we will take the weight for the respective sieves and we will fill in the observation sheet. In our case, after sieving the material, the metal passes through 63 retained on 50 nil and metal passes through 50 mm retained on 40 mm is 415 grams. The material which passes through 40 retained on 25, 10,285 grams. Similarly, 25, 20, 5475. So we will take all the weights. Similarly, we will take the weight for retained material from elongation gauge. In this case, suppose material passes through 40 retained on 25. If you will check through elongation gauge, it came 115 grams. So now we will take the weight for this sample passing through 40 and retained on 25, 115 grams. So we will take the, similarly we will take the all weights. Now we will take weight of retained material which passes through 25 and retained on 20. So it came 1010 gram, and material which passes through 20 retained on 16, it came 385 gram. So similarly we will take all the values. and we will add. This is the weight which are retains on the elongation gauge. This is the total weight. The elongation index is equal to retained material divided by total weight into 100. In our case, the elongation index came 15.15%. The combined flakiness on elongation index should be less than 30%. Previously already we calculated flakiness index 4.1% and now elongation index is 15.15%. If you add these two values, it came 19.28%, which is less than 30%. So this metal is satisfactory metal, which in elongation and flakiness index category. So we can use this material in WML. I hope you understand how to calculate elongation and flakiness index. In this video we show that how to calculate elongation index. Thank